Hello everyone. So today we are going to solve our day 19's question, that is do some problem on Leetcode. So this is a very easy problem. Here it is even mentioned that it's an easy problem, but there are some variations to it. There are two variations basically, right? Hmm. Let's first read the question and then I'll tell you what are the variations. So given an integer nums and an integer target, return the indices of the two numbers such that they add up to target. You may also assume that each input has would have only one solution and you may not use the same element twice. You can return the answer in any order, right? So here, if we just copy this and this, right, just copy it probably and paste it here, right? So simple to understand, right? Very simple to understand. We are given a target 9. So basically we have to find two elements, x plus y, which should be equal to target, right? And x and y should be from the array given, right? Let's try to think about it. If we take x as 2, if we take x as 2, what should our y be? Y should be 7, right? It should be equal to 9. This this place is empty, right? So we'll find that, hey, this is my brute force, by the way, right? This is my brute force. So is 7 present in the whole array? You will say yes, it is present. Okay. So you will return the answer as 0 and 1. Why? Because 2 is present at 0 index and 7 is present at first index, 1 index, right? So if I was given target as probably, 17 days, okay, fine. I can take 2, right? I can traverse the whole array. Hey, 15 is present, okay? Because 2, it something has to be equal to 17, right? So what can be equal to 17? So you have to say that, hey, if I have to find y, I will say that y is nothing but 17 minus 2, which is nothing but 15. Then you will traverse the whole array and find what is this. For 7, then let's just say if 2, 2 and the other number does not make the target, then you will start from here. Let's say 7. Okay, let's take some other example. Probably, yeah, probably this example works fine for that thing. Fine, pasted. Then I'll say that, hey, let my first number be 3. Then 3 has to be, something has to be here. And if you subtract 3 from 6, you will get 3. But here it is written, you may not assume the same element twice. So I cannot take 3 again, right? So I'll have to find other element. So 3 cannot, if I'm here, I cannot take any other because they won't add it 6. Then I'll come here, 2, right? Now I have to traverse the whole array again, right? But one thing is for sure that, hey, I've already checked 3 and 2 together, right? Do I need to check 2 and 3 again? No, right? Doesn't make sense. So what you'll do is you will traverse the elements which are after that I. Basically, the element I you are considering as your x. So you'll have to traverse for y, which is I plus 1 till n. Fine. So I'll take 2 here as x, and I'll have to assume something which, so what should be my y? Y should be 4, right? And you will find that, hey, 4 is present. So answer will be what? 1 comma 2. Simple. What will be the brute force look like? Very simple. So for I, which will start from 0 and go till n minus 1, right? I'm getting a call. Ignore it, right? Maybe, right? I'll start another loop. Right? Give me one second. Let me attend this call. Yeah. So now I'll start my J loop, which should start from I plus 1 as we discussed, right? It should start from I plus 1, again go till n minus 1. I'll check that if my array of I plus array of j is equal to target, I'll return I and j, return I comma j. Simple. What is the time complexity? Running two loops will give me almost O of n squared. Phase complexity, not taking any extra, so O of 1. Great. Now comes, see, there are two variations like I was talking about. First variation is you have to return the indexes, right? Second approaches or second variant of this question could be that you just have to return yes or no, that if the target can be found or not, right? In that case, you won't be given this answer that hey, exactly one solution is present there, and see, this will not be given because an answer could be no as well, right? There could be a case where the target is not matched for any of the indexes, right? So that is another solution. Sorry, another variation of it. Both will work with the same, same thing. You can, for in brute force, for example, you can return yes here, and if the whole loop is ended, then you can probably return a no here, right? No can be returned. So that is fine. But when you go to a better and optimal approach, you kind of have to see the question, right? If the variation one, that is the one that we are solving right now, it can be solved with one other solution. But the other variation that I'm talking about, it can be solved using what do you call it? It can be solved using two pointer approach as well. We'll discuss that as well, don't worry, right? We'll discuss that as well. But now let's see a better approach. I will say that hey, this is my array given, right? This is my array given to me. I'll say I'll have an object like hash map, maybe hashing. Hashing can be done. I'll traverse the whole array and save the indexes. So 3 will be, mapped with 0. So 2 will be mapped with 1. 4 will be mapped with 2, right? Then I will traverse the whole array. 3, 2, 4 is given. My I is at this point. Target is 6, right? Target is 6. What is the complement of 3? Complement is basically when you subtract, when x plus y is equal to target, and you already know what your x is, you have to find your y, which is 6 target minus x, right? That is your complement. So complement will be 3. Complement will be 3. I will see. First, here is some one thing that you will have to check. You cannot assume this 3 again, right? You cannot take I and value of this equal. So see, I is also 0. This is also 0. So you cannot take this. Other than that, is the 3 present here? You will say no, not present. Then my I shifts to this. What is the complement of 2? It will be 4. Is 4 present here? Re- Making sure that I is not equal to the basically the value of the key, right? Is 4 present? Yes, you will say yes, it is present. Then what will I return? I will return I will return maybe object of X or object of array of I, or maybe object of complement, complement, simple, very easy. But what will be the time complexity? My time complexity will be O of 2n because I'm running one loop for, filling the whole, what do you call it? The object. Then O of n for traversing the whole array again and checking the complement itself. What is the space complexity? I'm taking an O of n extra space, but I somehow found in my probably, I'm not sure. Still, don't quote me on this, but finding here, right, when I'm traversing this whole thing, I am finding the value in my object. Right? It kind of takes O of log n, right? It takes O of log n, right? I think what it uses is basically why I'm saying this is in languages like C++ and etc. There's a map thing. There is a thing called unordered map, right? And this is an unordered map only, right? You are saving the value. You're saving the value for every unique key. You have a value, but you have a pair, right? Key value pair. So you have for every unique key you have a value, and this is unordered because as you are here 3 will be here then 2. May If it was an ordered map, then you would have to have two here. Uh, I think for ordered it should be O of log n, but I'm still not sure. Like I said, don't quote me on it. It probably is O of log n for unordered, but I'm still not sure. It could be for ordered list. Not sure, but yeah. So we are taking an extra space. So O of n and O of log n. So this is what your time complexity looks like, right? But now the point is your and there should be multiplied, I think, because you're finding every time, right? So O of n log n maybe. O of two n is not n log n plus O of n. This should be the time complexity, not 2n. O of n log n plus 2n O of n, right? This is how the optimal approach looks like. But here also, you will use a two-pointer approach. You will use a two-pointer approach. But this solution is not kind of optimal for the variation that we are solving. The point is that we will not be reducing any space. We'll still be using the same, maybe what do you call, same time complexity and space complexity. So you can consider it as an alternative optimal approach or a better approach, or you can use this optimal approach maybe for the other variation that I was talking about. This will solve this particular approach will solve the maybe the variation two better and not variation one. As far as this variation goes, we have already kind of solved it here. Right? But see, you still need to know the optimal approach. Maybe if that question comes, this is the array given. What if I sort it? I say that hey, this is 2, 3, 4. I don't need to return any, what do you call any indexes of the target found, right? X and Y. I don't need to return the indexes, right? So what will I do? I will keep one pointer here and one pointer at the end. Perfect. Great. My target is 6. What is my I? My I is 2. And what is my array of j? It is 4. 2 plus 4 gives me 6. You will say yes, return a yes now. So target is equal to this. Had I been given target as not 6 but 5, right? Now I is 2 and array of j is 4. You will say that 2 plus 4 is 6. Assume, remember the thing that the array is now sorted. You have sorted the is my 6 greater than my target or lesser than my target? This is something that you will ask. Okay, if my target is greater than, maybe call it sum, is my greater than call it, is it greater than sum or lesser than sum? For this case, if the target is 5, you will say that it is lesser. What if I bring my j back? What if I decrease my j? Will it give me a lesser sum or a greater sum? Just think about it. If I bring my j back, that means I'm reducing the indexes from behind. That means I will get a lesser number than what I had array of j. Because here this array is sorted. The worst case is that I can get a 4. The worst case is I can get a 4. No problem. I will again decrease it. But what if all the elements are unique? Then for sure I will get my array of j as a smaller number, and then I will check it. Now j is at this, so 2 plus 3 is equal to 5. And is my 5 equal to target? Yes. But what if your target is now given as 10? Hmm? You will first check this is 6. Is my target greater than sum? Yes. I will say I plus plus. Why I plus plus? See, if I bring my I here and my j is here only, if my j is here only, I am sure that my array of I is smaller, and if I increment my I index, that means I will probably get a larger number than what I currently have as array of I. It's for sure, because since this array is sorted, then the sum of these two numbers will be the sum of these two numbers will be smaller than the sum of these two numbers. This is for sure. So 2 plus 4 is lesser than 3 plus 4. For this is very obvious. Then I will move plus plus. And here you have considered the both the variations first of all, and you have now learned two-pointer approach as well. If target is greater than sum, I plus plus. If target is lesser than the sum, j minus minus, because you will decrease from behind. And if target is greater than sum, you will increase from front, right? This approach can be still used for the variation that we have. This is the variation that we have. Okay? I will copy and paste this here. But now I have another thing which will save, which will save 2 comma 0, 7 comma 1, 11 comma 2, and 15 comma 3. What is this? This is an array which stores an array. And what does that child array stores? It stores value and stores index, right? And now I can sort this array again. So it will give me, maybe 2, 0. Then it will give me, oh, it is already sorted. So you don't need to worry about it. It's already sorted. So then I can iterate my, I can put my I here, J here, right? Since it's already sorted, I can put my I here and J here. And then I'll check the array, the child arrays, 0th index, right? The first index is a value. So if array of I of 0 plus array of j of 0, that is 2 plus 15, is it greater than my sum or lesser than my sum? You will say that it is greater than your sum, right? Target is less than what you are getting now. Target is lesser than sum. J minus minus, j comes here. Then you will check 2 and this, okay, till greater. Then you will bring your j here. Oh, it is equal to your the sum is equal to your target. Then what you will return is array of I of 1 and array of j of 1, because it stores the index, right? The previous approach for this, this, uh, what is the time complexity that it takes? It takes O of n log n for sorting, then O of n for traversing the whole array. Space complexity constant, not using any extra space because we are not saving anything. But particularly for this approach, the variation that we are on, what will it take? The time complexity will be O of n log n for sorting, O of n log n for sorting, plus O of n for for this two-pointer approach. That is fine. But again, we are taking an extra space of O of n into 2, because n there are n children, sorry, not child, sorry, n children. And what is the length of every child? It is 2. So n into 2. This is a space complexity. That is why this approach is not fine for this variation, but it will be definitely good for this particular variation. That is where we have to return yes or no. Let's try to code it now. I'll say that, hey, let number to index, it will be an empty object. Fine. Great. What I will do is I will run a loop from I, what is n? It is nothing but nums.len I plus plus, right? I will say that, hey, my number to index is of, maybe nums of I is equal to I. What is this? This is the key and this will be the value. This is the key, this is the value. Great. Let's try to console this out first and see what are we getting. This is what we get. 2 is mapped with 0, 7 is mapped with 1. Similarly for this thing also, 3 is, why is it so? Okay, yeah. 2 is mapped with 1, 3 is mapped with 0, 4 is mapped with 2. Great. So we are getting the value. Correct. Now I will run another loop to check that, hey, R is my complement present. So let complement is equal to target minus array of I. Sorry, not array of I, it's nums of I. If my complement is present in my object and there is one more thing that we are forgetting to check if that is not equal to the I is not equal to the value of that key, right? Because we don't need the same number again. And this object of nums of I, that is the value is not equal to I, then simply return me I and of nums of I, right? Here you can return an empty object, doesn't really matter. Let's try to run this and see if we are even getting this. Okay, we are not. We are not. Great. Why are we not getting it? Is complement in if complement is okay and number to index of nums of I, not nums of I think it should be complement. Complement. Then, oh, sorry, I have to return that and not this complement. Yeah, sorry. Sorry, guys. Perfect. Perfect. I'm sorry for that little mistake. I mean, I hope you understood, right? So if complement's value is not equal to my index, then I'll have to return this. And let's try to submit it now. Hopefully it should run. Hopefully it should. And it does. And it does, right? What is the time complexity here? Oh, sorry. What is the time complexity here? It is O of n for this thing, O of n for this thing, and for checking this thing, it could be O of log n. Right? So O of 2n and space complexity, we are taking an extra object. So yeah, there would be O of n only, right? So we have solved your question, though it could have been solved by sorting as well in a two-pointer approach. But again, like I told you, it doesn't really solve our problem. In fact, it will be taking O of n log n plus O of n to get take everything inside the object. Doesn't really matter if you get a different variation, then you can probably work with that, right? So I don't think we need any notes here, but okay, take an object to store the value as well as the index of arrays, then search in the object if complement is present at which index. Let's try to save this and mark it as done, right? Mark it as done. So this was a very easy problem. You can probably solve it on Coding Ninjas because I think Coding Ninjas takes basically it includes the different variation. There are other variations that I'm talking about. You can probably solve that as well. So thank you so much for joining in. I am not sure why the some problem is not mentioned here. Probably Cyber must have, it also takes basically what do you call the two-pointer approach as well, but you have to still run a loop. So it will take me O of n square. I think if some problem takes O of n square as the best approach. So yeah, you can solve that as well. See some problem. Tomorrow we'll solve the four sum problem. Right? I'll see you tomorrow with another video. Thank you so much.